Welcome, this is a recorded presentation of our ICFC paper towards auction-based function placement in serverless fog platforms. My name is David Bernbach and this is joint work with Zetari Maksudi, Jonathan Hasenburg and Tobias Pfandzelter. Without FAS, applications have to provision their resources as either virtual machines or containers. These, however, are usually idle most of the time. With FAS, in contrast, resources are provisioned only in small time slices, which leads to a higher resource utilization. This efficiency improvement is particularly relevant at the edge where resources are limited. When using FAS across edge, fog and cloud, requests will usually arrive at the edge. Ideally, we would also service all requests there to achieve the desired latency improvements. If, however, an edge node is already overloaded as shown in the figure, we have three options. First, we can reject the request, which is undesirable as it lowers the availability of the application. Second, we could queue the request briefly and service it later. This may not always be possible depending on the number and size of parallel requests. Third, we can offload one or more of the requests towards the cloud. Likewise, if the next node is also overloaded, it will continue to offload the requests. In this talk, we will focus on offloading. But how can we pick the requests that should be offloaded? In this vision paper, we propose to use an auction mechanism. Application developers bid on resources when they deploy their function. At runtime, when a node is overloaded, it uses these bids to offload the requests with the lowest bids. There are several benefits of this approach. The key benefit is that the decision can be made entirely local. This means that the system has no scalability limit. It's also easy to implement, leads to an efficient resource allocation, and maximizes profits for edge providers. This could be the key driver that makes edge-as-a-service business models feasible. Finally, we can have separate bids for storage and execution, which provides fine-grained control and also opens up interesting research directions. So how does it work? At deploy time, the function developer provides the function executable and two bids, one for storing the executable and one for execution. We'll cover the execution bid in a second. The function developer broadcasts this tuple to all FAS nodes. Each node then decides locally whether it can fit the executable into its local storage or not. In the latter case, the node will decide whether to reject the new executable or to evict one or more already stored executables. For this, the node can rely on the storage bids. For instance, the node could use a bin packing algorithm weighted with the storage bids to decide on the best storage option. All nodes start billing the storage price as soon as and while they store an executable. While the storage bid is used to charge per unit of time, the execution bid is the price paid per execution. It is important to note that both bids could actually be surcharges on top of a base price which would only be paid in the cloud. When now several requests arrive at a compute node, it has to decide whether it has sufficient resources to execute all of them. If not, the node has to pick a subset for execution and offload the rest towards the cloud. As the cloud offers at least the illusion of infinite resources, all requests will eventually be executed in the cloud when they don't find a node nearer the edge that can execute them. For the selection of the subset that the node wants to execute, it can rely on the execution bid. The easiest way would be to order concurrent requests by the execution bids, then to accept requests until there are no resources left, and finally to offload all other requests. Of course, there are better strategies. This already brings me to the end of the talk, as this video is intended to give a brief overview of the key ideas in our paper. In the paper you can find many more details. Also, the pick a subset part in the figures is an interesting direction for future research, which we discuss in the paper. Finally, we developed a simulation tool and used it to evaluate the effectiveness of our basic strategies. This can also be found in the paper. Thank you for your attention. Below you can find the link to our paper and also my contact details. Feel free to reach out to me with questions or comments.